All right, this is the first video of level 2 questions. So we're going to have to talk about the discriminant. So do 8, 9, 10, and 11. So firstly, we have to calculate the discriminant, identify what kind of roots, and then pick one of those graphs that could be representative of the quadratic. So remember, the discriminant is the stuff that is under the square root in the quadratic formula. So b squared minus 4 is c. In order to find the discriminant in A, I have to make sure that I'm in standard form. So I have to subtract the 10 over. So this is actually the quadratic that you are finding the discriminant of. So what I have to do, my A, B, C are just like the quadratic formula. So I'm going to find my discriminant is b squared, so negative 2 squared, minus 4ac. And we're going to type that into our calculator to get the value. 4, a here is 4, and c is negative 10. And I get a discriminant of 164. Okay? Now the discriminant is just 164. It's not the square root of 164. It is the number under the radicand. Now 164 is a positive number, but it's not a perfect square. If you don't believe me, try to take the square root of it, and you get a decimal. You do not get a whole number. So it is not a perfect square, so that means it's going to have 2 irrational roots. You need to memorize these rules. Is the quadratic factorable? No, not if you have irrational roots. And which graph would have 2 irrational roots? Well, C has no roots, B only has 1, A has 2 distinct roots. Not sure if it would be rational or irrational, but A would be representative of that graph potentially. Number 9, same kind of thing. So I'm going to calculate the discriminant first. So here I already have my graph or my equation set up in standard form. So my discriminant is going to be b squared minus 4ac. Alright, so that's actually going to be, let's see, I'll do it in my head. 25 minus 4 times 1 times 7 is 28, which is negative 3. That's a negative root solution discriminant, so you're going to have 2 imaginary roots. If I were imaginary roots, I cannot factor that quadratic. And imaginary roots never cross the axis because there is no real roots. So C would be the picture of what that graph could look like. If you're having trouble telling how many roots and what the nature of the root is, ask your teacher. We can give you a little bit more of a descriptive reason why. All right, number 10, also in standard form. So I'm going to go ahead and put this all into the formula for discriminant. B squared minus 4ac. Let's see, so that's 36 minus 12 times 3 is minus 36, which equals 0. If I have a discriminant of 0, that means you have 1 rational root. Any quadratic with rational roots can be factored, and 1 root means that you just come down and touch the axis. So that would be graph B. Finally, number 11. Calculate our discriminant one more time. We are in standard form. So let's see, I have b squared. So 1 squared minus 4 times 6 times negative 35. And those numbers are a little bit big for my head today. So let's see. 1 squared minus 4 times 6 times negative 35. 841. All right, so 841. Let's see. That's not a perfect square we use every day, but let's see if it is. Oops. It is. The square root of it is 29. So 29 squared is 841. That was not on our Know Your Power stuff last unit. The number and nature of roots, if it's a perfect square, would be 2 rational roots. Just like the last column, if you ever have rational roots, you are able to be factored. And this 2 rational means you cross the x-axis at 2 distinct rational numbers, which would look something like graph A.